Determine if the conclusion follows logically from the premises. First, we want to translate the premises and the conclusion into logic symbols. So the first premise is, if I upgrade my computer, we'll call it U for upgrade, then it will run faster. So U implies F. If I upgrade my computer, then it will run faster. That's our first premise in our argument. The second premise is, if my computer runs faster, then I will be more productive. There's the second premise. We want to know, does the first and second premise imply the conclusion, which is, if I upgrade my computer, then I will be more productive. So let's use a truth table to prove whether this is a valid or invalid argument. In our truth table, we're going to need three variables, U, F, and P. So we're going to have to consider cases for all three of these variables. This is going to be a very large truth table, because instead of the standard 4 cases for 4 variables, we're actually going to have 8 cases to consider. Okay, so true, 4 cases true and 4 cases false for the first variable. 2 cases of true and false for the second variable. True, true, false, false, true, true, false, false. And then true, false, true, false, true, false, true, false for the third variable. Writing it out this way takes into account all possible cases for all 3 variables. So we're breaking down our argument. We're going to need to know the truth values of U implies F, the truth values of F implies P, the truth values of U implies F and F implies P, the truth values that this implies, U implies P. Okay, so U implies F. We're interested in the truth values of U and F, and an implication is only false when the antecedent is true and the consequent is false. So both are true, both are true. Here the antecedent is true and the consequent is false, so that's false. Antecedent true, consequent false, so that one's false. Here it's automatically true when the antecedent is false. The implication is automatically true, so those are all true. F implies P, so we're just looking at the truth values of F and P. Both F and P are true, so the implication is true. Oh, in this case the antecedent is true, but the consequent is false, so then in this case F implies P would be false. Here automatically the implication will be true when the antecedent is false. So true, true, true. Oh, antecedent is true and consequent is false, so the implication is false. Here antecedent is false and false, so the implication is true and true. Okay, this implication and this implication argument is true only when both are true. Here they're both true, so the AND argument is true. Here one of them is false, so that's false. Here this one's false, so this is false. Here the first one is false, so this is false. Here they're both true, so then true. One is false, so this is false. Both are true in this case, so the AND is true. Both are true in this case, so the AND is true. So there's the truth values of this argument. We can't do the truth values of the implication yet. We need to know here this represents the antecedent in this implication. Here we've got, looking at this part, these truth values, this is our antecedent here, and this is our consequent over here. We need to know the truth values of our consequent. U implies P, so we're looking at U and P truth values. Okay, both are true, so this is true. U is true, but P as the antecedent is true, but the consequent is false, so then this implication would be false. Here, both are true, so this is true. Here, both, antecedent is true, consequent is false, so this is false. Here, for the rest of them, the antecedent is going to be false, so the implication will automatically be true here. Okay, so now we have our antecedent truth values and our consequent truth values for this implication. Here, both are true, so the implication is true. Here, both are false, implication is true. Everywhere that this antecedent is false, the implication is automatically true. Here, both are true, so the implication is true. Here, antecedent is false, the implication is true. Here, both are true, so the implication is true. Here, both are true, so the implication is true. Okay, so since the argument has all true truth values, this is a tautology. So this implies that the argument is indeed valid. Since we got a tautology with our truth table, we have a valid argument. It's true that if I upgrade my computer, then I will be more productive based on the given premises. An easier way to decide if the argument is valid or not for some of you, might actually be to draw an Euler diagram of the argument. So let's try that. It was, if I upgrade my computer, then it will run faster. So upgrading the computer is a subset of running faster. That's the first premise. The second premise says, if my computer runs faster, I will be more productive. So running faster is a subset of being more productive. Conclusion is, if I upgrade my computer, then I will be more productive. Well, since upgrading is a subset of faster, and faster is a subset of more productive, we can conclude that upgrading implies more productive. Here, it's a subset of being more productive, so therefore valid. There's no contradiction to the conclusion. There's no case where I'm upgrading and not making the computer more productive. There would have to be an upgrading outside of here, and it's not. They're all in here. They're all a subset of being productive. So there is how you show it with an Euler diagram, that the argument is valid. Much easier than the giant truth table that we just made. Another way to tell whether or not the argument is valid is when you do your translation of if I upgrade my computer, that implies running faster. When you translate to logic symbols, so here's the first premise. Second premise is running faster implies being more productive. Conclusion is, if I upgrade my computer, then that implies being more productive. Is if you recognize what type of argument this is, U implies F, F implies P, therefore U implies P. This is actually an example of hypothetical syllogism, or the transitive property, which is also known as the transitive property. So what we have is a chain of arguments here. U implies F, and F implies P, therefore U implies P. So we can conclude by the transitive property, we can also conclude that the argument is valid. That would probably be the quickest way to determine the validity of the argument, by recognizing that it's a hypothetical syllogism.